Assalamu alaikum everyone. My name is Ume Mahi. My ID is 242157794. Today we are going to present our project on 4-bit address subtractor circuit. This presentation is submitted to Somik Devnath sir, lecturer of CSE Department, Daffodil International University. Thank you sir for giving us this opportunity. Next slide please. Here is our team member. Next slide. Now I would like to give a short overview of our presentation. Today we will discuss introduction objective, components used, basic concept, working principle, circuit description, addition operation, subtraction operation, and finally advantages and applications. Let's start with the introduction. Digital electronics is widely used in modern systems such as computers, calculators, and mobile devices. Arithmetic operations are very important in digital systems. Among them, addition and subtraction are the most basic operations. Usually, separate circuits are used for addition and subtraction, but we can design a single circuit to perform both operations. This combined circuit is called a 4-bit adder subtractor. Now I'll pass it to Tommy.
Assalamu alaikum. My name is Taumi. My ID is 242156110. The objective of our project is to design a 4-bit adder subtractor circuit that can perform both addition and subtraction using one system. We aim to understand the working of 7483 IC as a binary adder and 7486 IC as an XOR gate. We also learn how to control signal switch operation and how 2s complement is used for subtraction. Now next slide. Now the component used in our project, we used 7483 IC for addition and 7486 IC for XOR operations. Input switches are used in binary input and LED display the output. We also use resistor for safety and breadboard for setup and connecting wires for complete the circuit. The circuit is divided into two parts.
Assalamu alaikum. Myself Arman Hussain Sani. My ID is 242150059. Now we arrive at the heart of our project, the basic concept of the 4-bit adder subtractor. So the fundamental question is, how can one circuit perform two different arithmetic operations, addition and subtractions? The answer lies in a control signal called Y. This signal determines what operation the circuit will perform. When y equals to 0 and the circuit performs addition. When y equals to 1, then the circuit performs subtraction. Now the component that makes this possible is the XOR gate. Every bit of input B is passed through an XOR gate along with the control signal Y, and here is what the XOR gate does. When y equals to 0, the XOR gate input equals B, meaning B passed through completely unchanged. When y equals to 1, the XOR gate inverts every bit of B, flipping zeros to ones and ones to zeros. There is one more important part. The carry in pin of the adder is also connected to Y. So when y equals to 0, carry in equals to 0. When y equals to 1, carry in equals to 1. These two things happening together, B being inverted and carry in being set to 1, is what enables subtractions. So we will see exactly why in the next slide. The working principle. Now let's understand working principle, the mathematics behind why this actually works. The XOR gate computes output equal B XOR Y, and the carry in of the adder is always equal to Y. Let's take case 1. when y equals to 0, it's called addition. B XOR 0 equals B, so B is unchanged, carry in is 0. Therefore, the circuit simplify computes A plus B. This is normal, straightforward binary addition, nothing special happening here. Now, case 2, when y equals to 1, it's called subtraction. This is where it gets interesting. B XOR 1 gives us B, the ones complement of B, meaning every bit is flipped. Carry in is 1, so the circuit computes A plus B prime plus 1. Now, B prime plus 1 is the definition of the 2's complement of B, and A plus the 2's complement of B is mathematically equal to A minus B. So the circuit is not directly subtracting, it is using a clever mathematical trick to turn subtraction into addition. This is called the 2's complement method, and it is the same method used in the ALU of every modern computer and processor. So that's all from my side. Now my next member will explain the other parts. Thank you.
Assalamu alaikum everyone. It's me Shushmita Sarkar and my ID is 2421539. Today I am going to present our project on a 4-bit adder subtractor circuit, which is a fundamental digital logic design used in computer. The circuit is built using two main IC. One is 7483, which is a 4-bit full adder, and the another one is 7486, which contains XOR gate. Now let's understand how the circuit is connected. The input A or A0 to A3 is directly connected to the input of the 7483 adder. However, the input B is first passed through the XOR gate before going into the adder. The most important part of the circuit is the control signal Y. The control signal is connected to all XOR gate and the carry in of the adder. The rule of XOR gate here is very interesting. They act as control inverter. If Y is 0, XOR output be unchanged. But if Y is equal to 1, XOR output the complement of B. So depending of the value of Y, the circuit automatically switch between two operation. If Y is 0, then addition, or if Y is 1, then subtraction. Finally, the 7483 adder product some outputs and a carry output. So with a signal in circuit, we can perform both operations efficiently. Please go to the next slide. Now let's show how the circuit works for addition. Here the condition is y is equal to 0. So the XOR gate don't change the B input. Also the carry in is 0. So the circuit simplified from normally binary addition A plus B. For example, A is equal to 0101, which is 5, and B is equal to 0011, which is 3. So the output become 1000, which is 8. This is just standard binary addition like we do manually. Please go to the next slide. Now let's see the subtraction operation. Here the condition is y is equal to 1. So the XOR gates invert the input B, making it B bar or B invert. Also, the carry in is 1. This combination perform 2s complement subtraction, meaning a minus 5. For example, a is equal to 0101, which is 5, and b is equal to 0011, which is 3. First, b become invert. B bar is equal to 1100. Then we add 1 with b, like 1100 plus 1 is equal to 1101. Now adding with a, then the result or output is 0010, which is 2. This is how subtraction is implemented using logical gate. So this circuit efficiently perform both addition and subtraction using a signal hardware setup just by changing one control signal. So that's all of my side. Now my next team member will continue this topic.
Assalamu alaikum everyone. This is Ummehani. My ID number is 242155795. Now I will talk about the advantage and applications of our 4-bit adder subtractor circuit. First, the advantage. A single circuit can perform both addition and subtraction. It reduces hardware complexity, which means fewer components are needed. It allows faster computation, and overall it is an efficient design. Now the applications. It is used in the arithmetic logic unit, also known as ALU. It is an important part of microprocessors and computers. It is used in digital calculators and also in embedded systems. So this circuit is very useful in modern digital electronics. Next slide please. To conclude, a 4-bit adder subtractor circuit can perform both addition and subtractor using a single hardware setup. In this circuit, IC 7483 is used as the main components for binary addition, and IC 7486 helps control whether the operation is addition or subtractor. The mode control input called M, who decides the operation. When M equals 0, the circuit performs addition. When M equals 1, the circuit performs subtraction using the 2's complement method. This design reduces hardware complexity and increases efficiency. That's why such circuits are widely used in the ALU of computers and other digital systems. Thank you everyone for your time and attention.